Hello and welcome to the tutorial on Excel Solver. In this video, I will solve an unbalanced transportation problem. So grab a mug of coffee and let us get started. Just a heads up, the Excel file I used throughout this video is available on my website. I will leave the link in the description below. The transportation problem we are trying to solve is the one you can see on your screen. The cost coefficients are already in the parameters table, so you don't need to worry about it. In this problem, we have two suppliers, A and B, and three destinations, 1, 2, and 3. Thus, the decision variables are the light gray cells. Let's start the setup of the constraint's right-hand side. In the first supplier constraint, the right-hand side value is 750. Type this value on cell F9. Then, the right-hand side of the second supplier constraint is 600. Let's type it on cell F10. Let's move to the demand constraints. The right-hand side of each one of these constraints is 540, 390, and 610. Type them on cells B12, C12, and D12 respectively. Perfect! Now let's check if the problem is balanced. Go to cell F11 and calculate the sum of the supplier's right-hand side. Type equal sum parenthesis F9 colon F10 parenthesis. Now go to cell E12, type equal sum parenthesis B12 colon D12 parenthesis. As you can see, the sum of the demands is greater than the supplier's capacities. Therefore, we must add a dummy supplier to the problem. Click with the right button of the mouse on row 6 and choose the option Insert. Now, let's add the new costs. In this problem, I will assume a dummy cost of 0. Let me fill the table. Alright, now let's add the dummy decision variables. Click with the right button of the mouse on row 12 and choose Insert to add a new row. The right-hand side of the dummy constraint is the difference between the capacities and demands. 1,540 minus 1,350, which is 190. So type 190 on cell F12. Let's recalculate the sum. Great! As you can see, now the problem is balanced. Our next task is to finish setting up the model. From now on, we are going to do the same things that we did for the balanced transportation problem. I will leave the link of the video in the description below. Keep in mind that I explained the details of the setup there. Back to the problem. Let's add the left-hand side of the constraints. In cell E10, type equal sum parenthesis B10 colon D10 parenthesis. In E11, type equal sum parenthesis B11 colon D11 parenthesis. Then, in E12, type equal sum parenthesis B12 colon D12 parenthesis. If you want, you can also drag down the formulations. Awesome! Let's set up the demand constraints. Go to cell B13 and type equal sum parenthesis B10 colon B12 parenthesis. Do the same thing for C13 by typing equal sum parenthesis C10 colon C12 parenthesis, and for D13 by typing equal sum parenthesis D10 colon D12 parenthesis. Then, finish the setup by finding the sum product between the decision variables and the objective function coefficients. Type equal sum product parenthesis B4 colon D6, comma B10 colon D12 parenthesis. Now, we are ready to solve the model. Go to the Data tab at the bar on top and open Excel Solver. Choose the dark pink cell as the objective function. Then, choose Mean to indicate that this is a minimization problem. After that, select the light gray cells B9 up to D12 as the decision variables. Press the button Add to start adding the constraints. On the first space, select cells E10, E11, and E12 as the left-hand side of the supplier's constraints. Then, choose the symbol less than or equal and choose cells F10, F11, and F12. Press Add to include the destination's constraints. Select cells B13 to D13 on the left-hand side and choose the sign greater than or equal. Then, choose B14 up to D14 on the right-hand side and press OK. Check the box Make Unconstrained Variables Non-Negative and choose Simplex LP as the solving method. Press Solve and then OK. Voila! The objective function value is $13,770. I hope that this tutorial clarified how you can solve an unbalanced transportation problem on Excel Solver. That's it for this video. Stay tuned to our upcoming tutorials on Solver.